Good afternoon. This is Geometry 9-1. We're working with translations. Our objectives: students will be able to identify isometries and find translation image of figures. Translations is just me sliding the figure around. It's putting the figure in a new spot. Essential understanding: you can change the position of a geometric figure without changing its size or shapes. These are called isometric transformations. So a transformation of a geometric shape is a change in position, shape, and size. So the pre-image is the original figure before a transformation. The image, the resulting figure after the transformation, and the isometry is an isometry is a transformation where the pre-image and image are congruent. So an isometric transformation is a rigid transformation. Now, identifying an isometry. For each transformation, does it appear to be an isometry? Remember, isometric transformation is a rigid transformation where the size of the image doesn't change. Okay, the pre-image and image are identical. In this first one, the pre-image and image are different sizes. So they're not an isometry, they're just similar. Here, the pre-image and image appear to be as if they are the same size. It looks like it's a reflection across this line that's between these two images. So if we show you this line, okay, and if I pull that line right across there, that's a reflection between the two. That's an isometric transformation. So yes, the isometry, size and shape are the same. And this last one, is this an isometric transformation? The pre-image and image look as if they're the same size. So this is too an isometric transformation. Yes, it's an isometry, size and shape are the same. Remember, what's an isometry? The size and shape are the same. When it's not, then the size and shape are different. Now, a transformation maps a figure onto its image and may be described with arrow notation. That's what this arrow is. This prime notation, that looks like an apostrophe, is sometimes used to identify image points. In the diagram below, K prime is the image of K. So K would be the pre-image. So the pre-image is over here, and this slides to be the image. Now, keeping in mind, when we talk about those, if I take we'll do this in black. If I take this shape, okay, this is my shape and it's my pre-image going to my image, okay, but that looks like it's been flipped. All right, so it's going to flip across my up and down. So it's, oops, excuse me, we're going to reverse that. It's left and right, I wanted to flip it. Okay, and that would have been flipped over there. So that's why K becomes K prime, J becomes J prime, and Q becomes Q prime. Now, naming images in corresponding parts. In the diagram, E prime, F prime, G prime, and H prime is an image. Remember, it's the final resting place of the pre-image E, F, G, H. And that's what they're saying here, that E, F, G, H maps to E prime, F prime, G prime, and H prime. So I'm asking, what are the images of angle F and angle H? So angle F prime is the image of angle F, and angle H prime is the image of angle H. What I'd like you to do is look at this next picture and you come up with the images of angle I and angle D. Okay, now that you've had the opportunity, keep in mind, NID and SUP order matters. N goes to S, I goes to U, D goes to P. So angle U is the image, the final resting place of angle I. And angle P is the image of angle D, the final resting place of angle D. So D went to P. Now, what are the pairs of corresponding sides of this first example? If I look at pairs of corresponding sides, what I want you to realize is that, okay, I've got EF, FG, GH, and EH, and they're going to be paired up with E prime, F prime, F prime, G prime, G prime, H prime, and E prime, H prime. This is just like we did when we were working with congruence, except we're talking about mapping from pre-image to image. So segment EF and segment E prime F prime. And notice the order I have in this mapping of my pre-image to image when I write this out. So I've got segment EH. Segment EH is going to correspond to segment E prime H prime. And now I'm going to look at segment FG in the same position, F prime G prime. And my last one, GH corresponds with G prime H prime. I would like you to use the order that we have here, and we won't use primes in this example 3 because we have primes here because they're the same letters to help associate the idea of one point to another. We're looking at N to S, I to U, D to P. So I want you to be thinking, what are the pairs of corresponding sides? Go ahead and line those up the same way I did in the previous example. Okay, now you should have NI to SU because order matters, and a segment ID to segment UP. And then the last one, segment ND or DN to PS. Okay, so that's what we do when we find our pre-image to image. Order matters and they are congruent, and the pre-image goes to the image. Or in this case, pre-image is the black and image is the blue. Sliding on. Essential understanding. The size, shape, and orientation of a geometric figure stay the same when you slide the figure in one direction. So if I slide the figure, it's called the translation. If I'm sliding it in one direction, I translate it across the plane. A translation is a transformation that maps all points of a figure the same distance in the same direction. A translation is an isometry. Able to recognize it, it appears as if I slid the figure. Now, if I slide the figure stays in the same orientation. I move it around the plane, but it is a translation. And the distance of the slide, corresponding points on the figure have the same distance. So B and B prime is the same as C and C prime and A prime. These distances are all the same. So when you translate a geometric figure, the size, shape, and orientation will stay the same. This is a rigid transformation. Now, when translating in the coordinate plane, you can say that each XY pair in the original figure is mapped to X prime, Y prime. If you moved a shape right 4 and down 2, you can use arrow notation to write a translation rule, such as XY maps to X plus 4, Y minus 2. Remember, right in the X area is an add. Left in the X area is subtract. Up in the Y area is add. Down in the Y area is subtract. Let's do some examples. If I have a pre-image of 2, 1, 3, 3, and negative 1, 3, let's graph these. So if I have 2, 1, if I go to 2, 1, 1, 2, 1, and that is my point P, and I have 3, 3, 1, 2, 3, 1, 2, 3, and that is my point Q. And I have negative 1, 3, 1, 2, 3. So now I have this figure, and this is my R, and I'm asked to put it someplace else in the grid. What I'm going to do is move my figure 2 points left and 5 points down. So each point will go 1, 2, 1, 2, 3, 4, 5. So this will be my R prime. And I'll go 1, 2 from Q, 1, 2, 1, 2, 3, 4, 5 down. And that is my Q. And from P, 1, 2, 1, 2, 3, 4, 5, down. So I've moved it around the graph, and this is now my image. And the red was my pre-image. Now, let's just double check to make sure that the points are right. I'm going to subtract 2 from each one of my x's. So 2 minus 2 is 0, and 3 minus 2 is 1, and negative 1 minus 2 is negative 3. I'm going to subtract 5 from my y's. 1 minus 5 is negative 4. 3 minus 5 is negative 2. 3 minus 5 is negative 2. Okay, so let's check this and see if it makes sense. When we did this, we moved it 0, negative 4. 1, 2, 3, 4. That's our P. Okay, that's our P prime, and I should put those in prime. That's my P prime, and that's my Q prime. And I went 1, negative 2, 1, negative 2, 1, 2 for Q prime. And I went negative 3, 1, 2, 3, negative 2 for R prime. So that's my changed figure from pre-image to image. I want you to give this next one a try. Go ahead, do exactly the same that I did, and give it a try. First, you have to get A, B, and C graphed. And we'll do that in red. So I'm at negative 2, 2 for A, and positive 1, 1 for B, and I've got 0, negative 1 for C. That's my A. Now if I connect these, that's my original. And now I'm going to use my blue, and I'm going to add 1 and subtract 4 for A prime. 1, 2, 3, 4. So my A prime is right here. And I'm going to go to B. I'm going to add 1, go to the right, and subtract 4. Go down 1, 2, 3, 4. So that's my B prime. And then C, I'm going to add 1 and go down 4. 1, 2, 3, 4. Let's get a double check. Add 1, go down 4. 1, 2, 3, 4. Yep. And that should be my C prime. Now, this should be my figure, final resting place, my image. The red's my pre-image. So let's double check, make sure it makes sense. I'm going to take negative 2 and add 1. That's negative 1. I'm going to take 1 and add 1. That's 2. I'm going to take 0 and add 1. That is 1. And then in my y's, I'm going to subtract 4 from each one of these. 2 minus 4 is negative 2. 1 minus 4 is negative 3. And negative 1 minus 4 is negative 5. Let's double check. So my A prime is negative 1, negative 2, 1, 2. So let's see if I moved it over and went 1, 2, 3, 4. So it should be right there. I'm just a little off just because of my drawing afterwards. And then I'm looking at my B is going to be 2 and negative 3, 1, 2, 3. And my C is 1, negative 5, 1, 2, 3, 4, 5. So those seem to work. Let's try, make sure we understand this, kind of our self-quiz. Go ahead and do C and D. Make sure you can do them on your own. Okay, now that we're back, we're going to take the x's, I'm going to subtract 1 for each of my x's. So that's going to be 3 minus 1, which is 2. Okay, 3 minus 1, which is 2. And 0 minus 1, which is negative 1. And I'm going to add 4, according to this rule, to my y's. 0 plus 4 is 4. Negative 2 plus 4 is 2. And negative 3 plus 4 is 1. Let's see what happened to my graph. Now we're going to take point A, and let's go after point A. Okay, and we're going to take point A. We're going to go back 1, up 4. 1, 2, 3, 4. So this is our A prime. And now we're going to take point B. Back 1, up 4. 1, 2, 3, 4. And that is our B prime. And we're going to take C back 1, up 4. 1, 2, 3, 4. And that is our C prime. Now, keep in mind what I just did, and I'm going to show you by tracing this because I'm going to be honest, my freehanding them has not gone very well, and it'll probably be easier for you guys to see that I have just translated my figure 1 unit to the left and 4 units, 1, 2, 3, 4 units up. Okay, let's double check our points that we found. A prime is now, go from pre-image to our image point, that's our A prime, which is 2, 1, 2, 3, 4. Well, that worked. B prime, 2, 2, and C prime is negative 1, 1. Do the last one, letter D, and I'll come back on and we'll talk about the solution. Go. Okay, welcome back. And the last one, I've got 4, 1, and 1. I'm going to subtract 2 from all my x's. 2, negative 1, and negative 1. I'm going to add 3 to all my y's. 0, 0, and 2. Okay, now keeping in mind what that looks like on the graph. Okay, I'm going to take my A, I'm going to subtract 2 from it, 1, 2, and go up 3. 1, 2, 3. So this is now my A prime. And that was at 2, 0. And that makes sense. My B prime, subtract 2, go up 3. 1, 2, 3. And I'm just translating this around my graph. And I've got C prime, and that's B prime. 1, 2, I'm going back because of subtract, 1, 2, 3. And here's my C prime. Okay, and let's see if I can freehand this better. And that's my image of triangle ABC under this rule, okay, this translation rule that I was given. Now, a move to the right, horizontal or up, vertical on the coordinate plane is positive, so I'm adding. Okay, that's why I added. Okay, a move to the left horizontally or down vertically on the coordinate plane is negative, so I subtract. Okay, so keep that in mind as we're stepping through these. Let's try these one more time. Okay, graph the image of the figure under the given transformation to the right 3 units and down 4. Identify the coordinates of each vertex. Well, if I transform to the right 3 units, I'm going to add 3, and that's to the x because x is left and right. Y is up and down, so if I go up, I'm adding. If I go down, I'm subtracting. So it's really a negative 4 here. Okay. And I suppose I had filled those in, so let's just double check to make sure I put that in there right. So we got 3 and negative 4. Again, I'm going to add 3 to all my x's. I'm going to subtract 4 from all my y's. So that's going to be negative 1, 0, 1, and 2. And you notice that it's easiest just to do that all at one time. It's a little bit more efficient to just add or subtract something from the x or add and subtract something from the y's instead of bouncing back and forth. 1 minus 4 is negative 3, 3 minus 4 is negative 1, 3 minus 4 is negative 1 again, and 1 minus 4 is negative 3. Now, I've got this, and keeping in mind that I'm just going to look at this, and I'm going to take my picture, math, and I'm going to translate it around the grid. And keep in mind that I'm going to go 3 units to the right, 1, 2, 3, and 4 units down, 1, 2, 3, 4. Well, then if that's true, I should have come up with A prime, and notice A prime is closest there at 0, negative 1, and M prime at negative 1, negative 3, 1, 2, 3, okay? And I should come up with T prime at 1, negative 1. And I should come up with H prime at positive 2, negative 3. Okay, so that's where my figure lined up. Okay, and I should probably pull that down just a little bit so you can see where those things are. Now, graph the image of the figure under the given transformation to the left 5 units and up 2 units. Identify the coordinates of each. If I go to the left 5 units and up 2, I will be off this grid. So what I want you to do is just give me the points. Instead of graphing it, give me the points this time. Go. Okay, you should have been able to come up with a rule knowing that left and right are x's, up and down are y's. And remember, left is subtract and right is add on the x, and up is add and down is subtract on the y's. So we should have been able to subtract 5 because I'm going left, and I'm going to add 2 because I'm going up. So I'm going to subtract 5. Negative 4 minus 5 is negative 9. Negative 3 minus 5 is negative 8. Negative 2 minus 5 is negative 7. And negative 1 minus 5 is negative 6. And then 1 plus 2 is 3. 3 plus 2 is 5. 3 plus 2 is 5. And 1 plus 2 is 3. So that should have been my points that I was able to do. And again, I wouldn't have been able to graph it because this graph paper is too small. Now, writing a rule to describe a translation. You've seen the rules. I've provided them for you. And how you write them. You go from one point, the pre-image, to the image at corresponding points. Let's do our x. So let's talk about an x position. So if I go 1, 2, 3, 4, 5, 6, 7, 8 units to the right and 2 units down, I'm going to add 8 to the x and subtract 2 from my y. So that's what's going to happen. And this is how I write my statement here. I have xy maps to x plus 8 and y minus 2. So that's my rule that I will follow. I want you to try it. Write a rule that describes the translation u v w x y to u prime v prime w prime x prime y prime. Be careful. Corresponding points should line up. And to check your rule that you wrote, grab a couple other points. 1, 2, 3, 4, 5, 6, 7, 8, down 2. And from Q to Q prime. 1, 2, 3, 4, 5, 6, 7, 8, down 2. Your turn. You do letter B. Now that you've tried letter B, you go from U to U prime. U to the right. 1, 2, 3. Maybe I should count these out so you can see what I'm counting. 1, 2, 3, 4 to the right. Down 2. So I went 1, 2, 3, 4 to the right, 1, 2, 3 down. And that would force this rule. 4 to the right, 3 down. Let's double check it. It doesn't hurt me to double check, and it only helps. I'm going to try X. 1, 2, 3, 4. 1, 2, 3. 4 to the right, 3 down. Totally works. Okay. Now, what is the rule that describes the translation A, B, C, D to A prime, B prime, C prime, D prime? Check it out. Go ahead. Now, to go from A prime, remember A and A. Be careful. I'm going back 1, 2, 3. I'm going down 1, 2, 3, 4. Back 3, down 4 should give me an X minus 3, Y minus 4. Let's double check. Remember, it's about corresponding points. So I'm going to go from C. 1, 2, 3, 4. Excuse me, back 3, not 4, but back 3. So I got to erase that 1 that I did there. So let's do that again. 1, 2, 3, and down 4. 1, 2, 3, 4. Totally works. It seems silly to check, but it seems even sillier to miss something because I'm just counting. Okay? You guys go ahead and do D, or actually read D and think about it. The translation of LMN to L prime, M prime, N prime was provided. Okay, find the coordinates of the pre-image. Find the coordinates if this was the rule that they followed. Now remember, this is a rule we just found. We just found this rule. How would I go from my final destination back? I want you to think about that. How would I go from my final destination back? Let's talk about maps for a second. If I printed off the direction to a friend's house and I followed it from point A, point B, point C, take a left, take a right, and stuff, how would I go backwards? I would start at the bottom, and where I took a right before, I'd take a left, and then I'd work my way up. So to undo something that's add, I would subtract. To undo something that's subtract, I would add. So you got to keep in mind, if I landed at -2, to undo add 4, I would subtract 4, it should be at -6. 1, to undo subtract 1, I'd land at 1, or adding 1 to it. So let's just double check. 2 minus 1 is 1. -6 plus 4 is 2. -2. Why don't you try the other 2 that are left? So hopefully you found that -4 minus 4 is -8. 3 plus 1 is 4. -2 minus 4 is -6. 6 plus 1 is 7. So hopefully that's kind of coming in your head a little bit. I'm just reversing the rule in order to get back to where I started. Now, Lesson 9.1, Translations. Objectives. Students will be able to identify isometries and find translation image of figures. Okay? Now, we're just going to do this. How to find the preimage from the image. How do you use the rule in the coordinate plane to go from the image back to the preimage? Hint, how do you reverse the directions? What changes must you make? It's what we just did. So find the preimage of A, B, C, D, of A prime, B prime, C prime, and D prime. So remember, we reverse. So -1 minus 1 is -2. 2 plus 2 is 4. Okay, -1 is a y, and add 2, it's 1. 5 is an x, and I subtract 1, which is 4. -4 is a y, add 2, I'm undoing, is -2. And 2 minus 1 is minus 1 is +1. And my last x, -1 plus 2 is 1, and -3 minus 1 is -4. What I'd like you to do is try B. Go ahead. So at B, you're looking at -3 minus 4, which is -7, and 1 plus 3 is 4. 0 minus 4 is -4. -5 plus 3 is -2. 3 minus 4 is -1. -5 plus 3 is -2. 3 minus 4 is -1. -2 plus 3 is 1. We're just reversing. So do this for your last thing. Okay. So now I'm looking at 2 minus 1 is 1. 7 plus 5 is 12. Remember, I'm reversing, going from my image back to my preimage. 2 minus 1 is 1. 2 plus 5 is 7. 5 minus 1 is 4. 3 plus 5 is 8. 5 minus 1 is 4. And 5 plus 5 is 10. Now, we're going to look at this. Composition of transformations is a combination of two or more transformations. In a composition, you perform each transformation on the image of the preceding transformation on the image of the preceding transformation. Okay, this is a typo, so we're going to take that out. So you just kind of keep moving it along, okay? You perform each transformation on the image of the preceding transformation. In general, the composition of any two translations is another translation. So composing translations, this is what this means. Okay, in the diagram at the right shows two moves of the black bishop. Okay, this is move 1 and this is move 2. If I use move 1, and remember, moving to the right is positive, moving down is negative. If I use move 1 as 1, 2, 3, so I'm adding 3 and down 4. 1, 2, 3, 4. Actually, I got to move over 4, don't I? 1, 2, 3, 4, down 1, 2, 3, 4. So I should have gone +4, -4, okay, from my original position. Now, from this spot, my second move of the bishop would have been 2 units to the right, adding 2 to x, and 2 units up, adding 2 to y. So that's my next move. What if I just wanted one move? What's the resulting move from my original position of my bishop to where it ended? If I look at that, it's 1, 2, 3, 4, 5, 6, and 1, 2. So if I add my moves, 4 plus 2 is 6, and -4 plus 2 is -2. That's my resulting move, my composition. So I'm combine these two moves to be just this one move in the same move. So let's see what that might look like. Okay, you find your single translation that will go from the starting point to the final destination. To start with this though, let's have you take your grid and mark it up. 1, 2, 3, 4, 5, 6. To the right, down 3, make a dot. Now, you visit Washington, D.C. from the American History Museum, and this is the American History Museum. American History Museum. So let me get that on there and I'll pull that up. That's the American History Museum. Okay, you walk 5 blocks east. Now, this is north. This is south. If I can get south in there. Let's delete that for a second. Let's put that south there. Okay, this is west, and this is east. Okay, so we're talking about north, south, east, and west. Okay, news. Now, you walk 5 blocks east. Let's get my blue out here. You go 1, 2, 3, 4, 5 blocks east, and 1 block south. Okay. Okay, this is the Air and Space Museum, so that's AS. Let me fix that. Well, that didn't really work real well, did it? So that's the Air and Space Museum. Then you walk 8 blocks west to the Washington Monument. So this is my next one. I'll do that in red. 8 blocks west to the Washington Monument. 1, 2, 3, 4, 5, 6, 7, 8. And this is the Washington Monument. So let's do that. Washington Monument. So I'm there at the Washington Monument. Where is the Washington Monument in relation to the American History Museum? So first of all, we did 5 blocks, 1 minus 1, and we went 1, 2, 3, 4, 5, down 1. And that's my first one. And the second one, and let's make these, okay, was 8 blocks west and nothing else. Now, keep in mind, I just add these up. So what's 5 plus -8? That's going to give me a -3, and -1 plus 0 is -1. So let's check this out from my from the Air and Space, my American History Museum. From American History Museum, I go 1, 2, 3, and down 1. And that's what my final result is. What I want you to do is try the same thing in the book fair. Except before you start, let's put a black dot. 1, 2, 3, 4, 5, 6, 1, 2. Please put that black dot down and then give it a try based on these directions. Okay, and after you're done, turn me back on. Okay, you and some friends go to a book fair where booths are set up in rows. You buy a drink at the refreshment stand. So you got RS. Okay, so I'm at the refreshment stand. That's at RS. Okay, you buy drinks at the refreshment stand and then you walk 8 rows north. So I'm going to go 8 rows north. 1, 2, 3, 4, 5, 6, 7, 8 rows north. And then 2 rows east. 1, 2. Oh, to the science fiction booth. So I'm at the science fiction booth, SF. Okay. So now I'm at the science fiction booth. Then you walk 1 row south and 2 rows west. So let's do that red. 1 row south and 2 rows west. 1, 2. Now, you're at the children's book booth. Okay, so you're at the children's book booth, CB. Okay, that's where we are when you finally have that red spot. Now, they're asking, these are the 2 directions. We just went 2 and then 8, right? And then we did the children's book booth, which was -2, down 1. Now, where are we? We're at 1, 2, 3, 4, 5, 6, 7 away. Okay, well, this is 0, and we're 7 units away. So hopefully that's what you got for your final spot where you're being. And remember, this is a simple little look at us talking about composition of transformations. So these compositions of transformations are a big deal, but it's not that hard. I just want to make sure that you understand them and that you kind of followed along with what we did. Now, the last things we have to do. The translation xy to x plus 10, y plus 15 maps PQRS onto P prime, Q prime, R prime, S prime. What translation maps the image back to the pre-image? Think about undoing. And it should be the reverse. And that's it. Okay? Now, in 9 and 10, these are your self-quiz. Okay? If triangle XYZ has coordinates x 2, 3, y 1, 4, and z 8, 9, a translation maps x to x prime 4, 7. What are the coordinates for y prime and z prime? Now keep in mind, I went from 2 to 4. Pre-image was x, image was x prime. So I've got to be thinking I went from 2, 3 to 4, 7. And I've got to be thinking, what did I do to go from y and z? What's going to happen here? I went from 2 to 4 is adding 2. I went from 3 to 7 is adding 4. So I've got my rule there. So now I can come up with the 2 missing pieces. So I've got that, 3, 8. 2 plus 1 is 3, and 4 plus 4 is 8. And I've got my z, 8, 9. 8 plus 2 is 11. Okay. Or excuse me, 10, and 9 plus 4 is 13. Now in 10, I want you to do the same thing. Now you turn it back on, triangle ABC has coordinates A, 2, 3, B, 4, negative 2, and C, 3, 0. After a translation, the coordinates of A prime are 6, 1, negative 1. You know, it went from 2 to 6, I added 4, and went from 3 to negative 1, which is subtracting 4. So I had this initially, and I find my rule based on that. After I find my rule, I apply it to the 2 other points. So I got my 2 other points, and I'm showing notation as I go. There should be a prime there. Let's make sure we get that prime in there. Okay, so I'm going to add 4, and I'm get 8, and I'm going to subtract 4, negative 6. Add 4 is 7, subtract 4 is negative 4, and that's my 10. Okay, now, summary. The objective, students will be able to identify isometries and find translation image of figures using rules. Write a couple sentences about something that you learned today about the learning objective, then rate yourself on a scale of 0 to 4. Thanks for your time today, you guys. We have the assignment that we'll do tomorrow in class, so keep that in mind. Tonight it was about you getting your notes done. All right, and that's it. Your homework will be tomorrow. Have a great night.